Dun 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 dun. Dun, 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 dun. We've done enough things that it can get confusing where you're trying to go. So I thought it might be nice to make a map to help you escape that confusion. The first question you're going to ask yourself is, what am I testing? And there are two answers to that question, but so far in class we've only done means because we've always worked with numerical data. Knowing that we're testing with means, you might say, okay, how many means? We might be testing one mean, or we might be testing two means. We started with only one mean, but at this point we need to pause and say, hold on, is this a cannot do question? There's a fence that you can't get past unless certain conditions are met. When we talked about one mean, there were two paths over this fence. One path was if it says that it was normal to start with. The other path was if n is greater than or equal to 30. So great, as long as one of these is in place, we can get past this fence. Now we know we're doing one mean and we have enough data. The next question is, do I have sigma or s? In other words, the standard deviation. Did it just magically know beforehand, or was it something that we had to get from the data and has error? If it was the magical sigma that we just somehow knew, that leads us to the one sample z-test for a mean. The hypothesis test is here, and we spent a whole chapter practicing this guy over and over. Or the confidence interval is down here. These are not different equations. These are actually the same equation. You take this and solve for mu, you get that one. Make sure that you're comfortable with that idea. Then if you know s, that takes you to the t-test. It says degrees of freedom n minus 1. That's not part of the calculation. That's just a reminder that you're going to need that. And the matching confidence interval down here. These are the one sample means tests. Over here, if we're talking about two samples, how do we get over the fence? It's the same two rules. Either it says it's normal or the sample size, both of them this time, because we're talking about two groups, have to be greater than 30. Once you know that you have enough data and we're looking at two means, the next question is, are we looking at matched pairs? If the answer is yes, that's going to lead us to another t-test that looks almost the same as the one sample t-test. We put some d's in here to remind us that we're supposed to be looking at the differences. The mu specifically is going to be 0, but otherwise these are basically the exact same. If it's not matched pairs, then let's check if it's a pooled test, yes or no. And I realize I'm kind of hitting the edge of my board here, but I want you to try to see how these two equations are very similar. Here's the hypothesis test with a t that has n minus 1 degrees of freedom. Here's the other hypothesis test, the degrees of freedom being n1 plus n2 minus 2. Here the confidence interval, the difference in the means, the t-score, and there's that piece that was in the denominator. The difference of the means, the t-score, there's that piece that was in the denominator. The big difference between these two is S1 and S2 are separate. Here, SP is a pooled standard deviation, which probably needs to be included on the map.
Write that down.
It's just an issue of my board's not big enough to fit it all in, so I need to buy a bigger board for my office here. But here's the map of all the different places we've gone, and there are patterns here. If you see the pattern, it will look like the same one equation, twisted and changed slightly to fit all these different scenarios, but not a bunch of different things. This map will continue to expand as we explore more. For example, we might be testing one proportion or two proportions or lots of proportions. And when we talk about means, those averages could be going in a line, or we could just have lots of averages across different categories. So we're going to expand on this map, but the idea of this pattern is going to be consistent and the same throughout it.